for adding and subtracting. We're going to try a couple more adding and subtracting, and then we're going to do the adding and subtracting ones where it's actually more advanced denominators. All right. So we have 8. Please paying attention with your mouths closed. And 4x. So the left side has an x squared. The right side needs an x squared, so we're going to multiply by x. The left side has an 8. The right side has a 4, so we can multiply by 2. And we can only do this and make them the same because they're both monomials, correct? If they're binomials, you can't do that. So we get equal sign 3 over 8x squared plus 2x over 8x squared. And we put our denominators together once again because they are monomials, correct? If they're binomials, we would just bracket, bracket, move on with our denominators. So then we're going to get 3 plus 2x over 8x squared. And x can't equal 0. That's it. Can't put these together. It's a 2x and a 3. They're not like terms. We can't cross off the 2x and the 8x because these are attached, correct? Done. So the second one, I have 2n plus 1 in the denominator. I can't take a GCF or anything out of it. The second one, I have n minus 3 in the denominator, and I can't take a GCF out of it. We agree? So this one I have to multiply by the other one, n minus 3. And this one I have to multiply by 2n plus 1. Now we distribute the numerators, the tops, but we don't the denominators because they're matching already. So we get 3n squared minus 9n over 2n plus 1 n minus 3 minus 8n plus 4 over 2n plus 1 n minus 3. Why don't I distribute the denominators? Why don't I distribute the denominators? Because they're the same, and then you'd be expanding instead of doing simplifying, which is what all these ask. So then we have to remember 3n squared minus 9n minus 8n minus 4. Remember that you have to subtract the 4. Make sure you did that. Negative 8n minus 4. And so I'm going to get over 2n plus 1 n minus 3. So I get 3n squared minus 17n minus 4 over 2n plus 1 n minus 3. I'm seeing some that are not correct. N cannot equal negative a half and 3. Alrighty, H. We're going to look at this bad boy. So, there are two binomials. Paying attention. These are actually easier. They look harder, but they're easier, right, Matt?
Yeah.
Put it away. Stop. I don't know what you're doing. Quit. Okay. So, if you look here, I feel like I'm an airline stewardess. If you look directly behind me, you will see, for people who actually watch this, I don't think anyone does, but you know, if you do, we're here. So this is a binomial and this is a binomial. We agree? And until this point, I don't know why I'm doing this. I feel like I'm punching someone. It's my aggression towards social. P squared minus 1 and then P plus 1. We get it? We see it? We like it. It's great. And then we go and we're like, ooh, I can't make the match. Or you're like, I can. I'm just going, and then you randomly do something. It doesn't work. Multiply by a P or something. Or you multiply them by each other. And you're like, I got some P squareds. So let's look at this. What we need to do is we have an addition. When we have an addition, we need to make common denominators. We agree? So what we want to do is make the easiest common denominator. We agree? Now in the past we had like x plus 3 and x minus 1, nothing in common. We had to multiply by each other. There was no options. Yes? Yes. If we look at, hey, I thought you put your foot down. And you gave the right answer. So Tony looked here and he said, I can square root this. Ooh, I can square root this. Ooh, it has a minus sign. Ooh, it's a... He did all of that. I just saw it. He just went like this. But I knew what he was meaning. Difference of squares. So the bottom here, p squared minus 1, is actually difference of squares. So I have to do that first. Sometimes it's a difference of squares. Sometimes it's a GCF. So always look in your denominators before you make a common denominator. Can I make it simpler that maybe makes them match? If you do this step, it actually makes life easier than the previous questions I gave you. Because right now they both have a p plus 1 in common. Check. The right-hand side just needs a what? P minus 1. It's easier than the other ones where you have to multiply them by each other. Bless you.
Sneeze on myself. It's better than into a mask.
No, not for me. That's for you. But for us, it's better if you sneezed into a mask. It is, but then moistly.
Breathe in hot air.
Trudeau said moistly. All right. So we have 4 over P plus 1, P minus 1. And then this one we distribute, 2P minus 2. So these questions, although they may have a little bit more of a step at the beginning, are actually easier to do because they make stuff match. And then on the bottom we have P plus 1, P minus 1. And then on the bottom we get P plus 1, P minus 1. And then on the top we get 4 plus 2, P minus 2. We can put them together because we have common denominators now, right? Are there any like terms in the top? Yes. The 4 and the 2, they both don't have any variables. Or what the word variable was for a second there in vegetables. Not true. So on the top we have 2P, and then 4 minus 2 is plus 2. P plus 1, P minus 1. And at this point, most people will box it. But you're not finished. Anything else you think you might be able to do? Yeah? Take out a 2 in the numerator. My speaking is rough today. It's not moistly talking, but it is incorrect. Striking. Now, what can I cross off? P plus 1s, but what must I do before I cross it off? Yeah, slap my hand and be like, did you state MPVs, Lepp? Because if you did not, you must, right?
MPVs missed that.
Thanks. A little late to the game on that one. Well. So if I do this, I'm going to go P cannot equal 1, right? And I'm going to be in trouble because my multiple choice won't match. You were on your phone, so you missed this step. Yeah. And then those canceled, and then we would get off to the side, P cannot equal plus or minus 1. And so I would get T over P minus 1. P cannot equal plus or minus 1.
Oh, you can take 2 of those.
Yeah. Mm-hmm. Does that make sense?
No.
I'm putting my foot down. Yes.
Can I put my foot down and go fill? Where's my water bottle?
It's in your bag. I can see it. It's in your bag. Turn your bag. Turn your bag.
Can I go fill my water
Yeah.
bottle?
Mm-hmm.
So you took a 2 out. You took a 2. You're taking 2 out.
Well, you're taking a GCF of 2 out. So 2P divided by 2 is P. 2 divided by 2 is a really big 1. Alrighty then. Let's go here. So I can lend you to want to do 5x plus 5 on one side, 2x plus 2 on the other. It can lend you to want to do this first. But if you spot something, it's actually way easier.
Take a GCF out of the 2x plus 2 and the 5x plus 5.
Yeah.
You can see that on the phone.
So we get a 5 out front here, and we're left with x plus 1. And then we take a 3 out of the right-hand side, and we're left with x plus 1. If you spot that, this is easier. Do you agree? If you don't spot it, you are going to have to do decomp on the top. You're going to have to actually factor the top because you made it more complicated. And take out GCS. So, x plus 1 is common to both, right? Yay, the variables are the same. Now the only difference is the right-hand side has your left-hand side has a 5 and the right-hand side has a 2, right? Can we make them be the same, those little monomials? Yeah. What can I multiply the right-hand side by? 5. And the left-hand side by? 2. So we get 8 over, and because they're monomials, we can put them together, 10x plus 1 plus 15 17 over 10x plus 1. And then I get 23 over 10 x plus 1. And then x can't equal negative 1. Let's look at that bad boy. Anything we could do? Take out an x. You'll see it in a second. Take an x out, and we're left with x plus 2. Yeah. So now both have x's, but the right-hand side has an x plus 2 and the left-hand side does not. So I have to multiply. Why is there an airplane? To multiply by x plus 2. Multiplied by x plus 2. When I distribute a 1 in, it changes nothing. So I'm going to get x plus 2 over x plus 2. You are going to have to try your hardest to not cancel those off. People will go cancel them. You just put them on. Don't take them back off. You won't have a common denominator. So we're going to get x plus 2 minus 1 all over x plus 2. Collect like terms. X plus 1 over x plus 2. Can I cancel anything off? Can I cancel anything? No. The top is an x plus 1, so it's attached, correct? And there's no x plus 1 in the denominator, so I can't cancel it. So I'm just going to be left with x can't equal 0 and negative 2. So now you're going to do, yes, Lemon just knowed me. Page 249, number 6. 249, number 6.